property. So property of CNT. So why this is wonder material? Why these things are considered to be future of nanotechnology? Because of its property only. Nanotechnology is nothing but it's a material science. I talked about it. It has potential to change the way of life we are living. And for that, it must be having some superlative and unique property that we are going to use in future, right? I'm taking CNT as a representative and we'll talk about it, right? So CNT, the first property that we are going to discuss is mechanical property. Which one? Mechanical properties. And in mechanical properties, there are 2 points. The first is its physical strength, its mechanical strength is 1,000 times better than steel, right? 100 times, you can say, like 100 times better than steel. So it is very strong if we compare with the steel. Steel is known to be very strong material, right? That is why all the structure that we create around is made up of what? Steel. But if you take the same thickness of CNT and same thickness of steel, then CNT is going to be 100 times stronger than steel. So you write first point, CNT is 100 times stronger than steel. 100 times stronger than steel. And 10 times lighter than aluminium. And 10 times lighter than aluminium. So 100 times stronger than steel and 10 times lighter than aluminium. I mean, aluminium is known to be, one material which are lighter. So wherever we need to create a light structure, like aeroplane, so there we use what? Aluminium, right? And wherever we want mechanical strength, then we use what? Iron. This is something which can give you both. It could be very strong yet very light, right? But you know that iron is not only used because of its mechanical strength. Iron is also being used because it has got another property that is called tensile strength, right? So iron has got a property of tensile strength. That means iron can withstand a pressure without breaking, right? So now railway track, you see that that track is made up of steel, iron, and 1,000 tons rail come over it. And then this track will go down, right? And then when the rail passes on, it will again come back. It will not break. You get my point? The iron is not going to break. It has got a tensile strength. These pillars which are made in this building, this pillar has got iron inside. You know that. So why this iron has been placed? So that the tensile strength can save this building from collapsing in the case of there is earthquake. You get my point? Because when earthquake is there, energy will come up. And this iron pillars, it will just, move. It will sway like this. And when it is moving, then that means this building will be saved. It will not break because obviously the tensile strength will save it. If tensile strength is low, then if you put the pressure, if you put force, it will simply break. Structure will go off. So iron is something that is known to have very good mechanical strength and very good tensile strength. CNT is better than iron in mechanical strength, and CNT is world's best material in terms of tensile strength. So if we compare the tensile strength, nothing can be compared with the CNT. So you can write one more point. Second point. And there you can write, in terms of tensile strength, CNT, in terms of tensile strength, CNT is among best material in the world. It among best material in the world, right? So that is CNT. In terms of mechanical strength, mechanical property. Second property is electrical property. Electrical property. Electrical property. So we need something which is good conductor. CNT at the same time can be very good conductor. Best conductor we have is silver, and we compare CNT with silver, then CNT is 1,000 times better conductor than silver. So same CNT showing very good mechanical property, and same CNT can be used as the best of the electrical conductor that we can have on this earth. So you can write one more point. CNT is 1,000 times better conductor. 1,000 times better conductor than 1,000 times better conductor than silver. 1,000 times better conductor than silver. So that is one thing. Third property is thermal property. Thermal properties. Right? And if you talk about thermal properties, then CNT is thermally very stable. If you heat CNT, if you give temperature to CNT, then in atmosphere, this CNT can bear, it can withstand with a temperature of 780 degrees C. So up to 780 degrees C, no deformity, nothing will change in CNT. It will stay there like that only. If you take it to the space, that means vacuum, when there is no gases, then it can withstand the temperature of 2,800 degrees C, 2,800 degrees C. So in that way, CNT is very thermally stable. Now the whole idea is that one CNT and you have all three properties which are superlative, right? Very nice properties. Normally when we want to have mechanical strength, we go to iron. When we want to have very good electrical conductivity, we go to silver. When we want to have a very good thermal property, then we can go for titanium and all. But now this CNT is one which is having all, right? So you can imagine how many things we can make out of it. You can write one more point. CNT has very good thermal stability. Very good thermal stability. It can withstand a temperature of 780 degrees C. 780 degrees C in atmosphere and 2,800 degrees C in vacuum and 2,800 degrees C in vacuum, right?